4.9. In 4.9, they want you to learn about both parallel lines and perpendicular lines. Okay? And we just went through and said, if, oops, I guess a pen would be good. If we have two lines, they intersect, and they form right angles, then we are going to have perpendicular lines. So what's really important about that is you're never really going to measure those angles, but after you're done graphing your lines, they better look like they're forming a right angle. Okay? They better look like there's some right angles there. And by the way, if one of the angles of those four is a right angle, the other four have to be, or the other four, the other three have to be. If one of them is a right angle, the other three have to be. There's no way for the others not to be. And that's something maybe you'll explore more when you get to geometry class. But if we have perpendicular lines and there is one right angle, that means the other three will be also. Okay, here's what we have to keep straight, the difference between parallel and perpendicular. How are we going to know if we don't graph them? Just from looking at the equations, how are we going to know if they're going to be parallel lines or perpendicular lines, or maybe neither? Maybe they're not either of them, they're just some intersecting lines. Okay, here's how we're going to know. And I want you to underline this right now. If slopes are opposite signs, so in other words, one is positive, the other one's negative. Doesn't matter which one's which. One is positive, the other one's negative. And, put a nice little box around that word and this also has to be true, are reciprocals of each other. Then we have ourselves perpendicular lines. So, there's an example here. Let's just look at the graph first of all. Do you think that it looks like where those two lines cross, even if you have to turn your paper a little bit, do you think it looks like where those two lines intersect, there are four right angles?
Yes.
They might not be exactly 90 degrees, but yes, they're right.
Okay. They have to be exactly 90-degree angles, but, you know, there could be when we actually measure and make it look really close because it's human people, not a nice big computer maybe measuring them, we would maybe get really close to 90 degrees. But yeah, it looks like they make square corners there. And here's another way that you could actually do it. If you take the corner of your paper and folded it kind of into one of those angle measures, and the corner of your paper fit nicely into one of those angles, I can't do it on my smartboard, and it fit nicely on one of those angles. So here's what I'm talking about. Okay, they're doing this. Okay, now, I didn't do a very good job though. Do a better job with this. Okay, if you take the corner of your paper, even, don't rip it off or anything, take one of the corners and see if you can fold it down into it. And what should happen is when you put a corner of your paper into that one of those angle measures, it should fit in there really nicely. It should just like slide right in there.
You did that so perfect.
I know, isn't that something I didn't do too bad after I redrew it? So you could just take your notes right now and you could take one of the corners, whichever one seems to work for you, if you can, and you can make it work and you can check to see if those make right angles there, do they? Or maybe you get out another sheet of paper that's hanging out close to you and use that. So when you're graphing them and you want to check to see if you have good graphs, that's how you can check to see. After you have your two lines, you can say, oh, just because remember what I said, if one of them is a 90-degree angle, then they all are. They all are. Okay. So how are we going to know, first of all, from the equations? Well, we're going to do the same thing we did with parallel lines. We're going to take the equations. There's three of them here in this example. These are the three equations. Two of those are graphed over here because it was decided they should be perpendicular. And notice what was done. The only thing done was the slope was figured out for each of them. Because here's the deal with perpendicular lines. We only have to compare their slope. They can have the same y-intercept or they don't have to have. So we could care less about their y-intercept. It's not like parallel lines. These guys can cross the y-axis at the same location if they want, but they don't have to. So the only thing we're going to compare, so would you make that little note here? Only compare slopes. That's all you got to do. You don't have to worry about the y-intercepts for these perpendicular lines. Only compare their slopes. But then, you have to know how to compare them correctly. You have to be able to say, oh, the rules were that the slopes have to have opposite signs. One has to be positive, the other has to be negative, and they have to be reciprocals of each other. So, well, here we have this -3 and a +3. Well, they're opposite signs, aren't they? -3, +3, those are opposite signs. So right now they would pass the test. But remember, we put a box around that word and we said, and are reciprocals of each other. Is 3 a reciprocal of 3?
Yes.
What are reciprocals? What does that mean?
They're
So,
opposite.
Not opposites.
reciprocals are
You put them
the
on
bottom number of a fraction.
Okay, so 3 can be made into a fraction by putting it over
Yeah.
1. Its reciprocal is also 3 over 1?
No, it's one.
Oh, 1 over 3.
It's 1 over 3. This is the reciprocal because we just have the numerator and the denominator trade places. So reciprocal of 3 over 1 is 1 over 3. Because here's the definition for reciprocals. The two of them multiplied together better give you 1. And if you took 3 times 3, you wouldn't get 1, would you?
No.
But if you took 1/3 times 3, would you get 1?
Yes.
Okay, so that means now we can't say that, we say, you know what, these two can't be, because even though they're opposite signs, they're not reciprocals of each other, so those two can't be, nope. But then we look and we say, okay, here we have this one, we have m equals -3, and we have m equals +3, or that's not the one I want to look at, I want to look at this one. M equals +3, here it's negative, so we have the opposite signs, and they are reciprocals of each other, 3, 1/3, okay? So we would say because 3 and 1/3 have opposite signs and are reciprocals of each other, these are the two equations that would be perpendicular to each other. And then they were graphed to prove it. Okay, let's practice our own, okay? Identify which two lines are perpendicular. Then graph the perpendicular line. So just two of them. So which ones are perpendicular? Well, they has to be in slope-intercept form first, and I think today they're going to be nice to you, and every time it will be in slope-intercept form. So the first thing you're going to do is just identify the slope for each of them. Dakota?
Okay, so we're gonna use line, or we're gonna use slope-intercept form, y equals -2/3 over 2/3 x plus 2, and y equals 3 over 2x plus 1.
Why are we going to use those first two, Dakota?
Because
The slope of the first line is what? What's the slope of this one?
it's negative,
-2/3.
and the other one is the reciprocal.
And the next one's slope is +3/2. And what's this one's slope?
Just
2/3, okay. So we, first of all, this might be the best way to do it. First of all, look for the reciprocals. I think that's what Dakota did. He said 2/3 and 3/2 are reciprocals, aren't they? Is 2/3 the reciprocal of 3/2 and vice versa? Is 3/2 the reciprocal of 2/3? And then, once you decide that they're reciprocals, then the next decision you say is, are they opposite signs? So because we have a negative in this one and a positive in this one, and they are reciprocals, we are going to say that they are perpendicular. I'm going to show you a abbreviation for perpendicular.
Is it PD?
No, it's not. Is it +1 there? Are perpendicular. There's the abbreviation for perpendicular.
Wow.
An upside down capital T. An upside down capital T. Okay. Now you guys are so good at graphing by now, right? You got this, don't you? Okay, would you graph those two lines, please? I will send some rulers back for you. Graph the points for one line, draw the, caution. Graph the points for one line, draw the line. Graph the points for the other line, then draw its line. Don't wait and do it after you've made all the points for both lines. It will get too confusing. So we are going to have to identify the y-intercepts for the ones after we decide what two are perpendicular, so that we have a starting point.
I'm on the backside too.
Yes, we are. And I want you to take something, the corner of the paper, or get out another, you can get out your loose leaf, that's gonna be for your homework right now, and you can use the corner of that sheet of paper. And after you have your 2 lines graphed, when you verify that you feel pretty good about 90-degree angles, you just have to check one, that's all you gotta do.
Are we just trying to box in
No, because that's still, we can have a box that's got a slanted side, right? So it doesn't necessarily guarantee that it's gonna have a, and I think what you mean is a square. The corner of the ruler works, good thought process there, Riley. Use the corner of the ruler. And then you can also verify by looking at mine, or if I need to be corrected, feel free to correct me. So the goal is that the graph supports the 2 equations we picked to be perpendicular. Correct. Did you have another question? One. Does anybody get questions about that one? Okay, what are we going to compare to decide if they're perpendicular or not? What's the only thing we have to worry about comparing?
So,
Slopes. So the first thing I want you to do is write down in number 2 here, I want you to write down what is the slope of each of these lines, because you're going to need it anyway at some point for 2 of them to graph them. So just go ahead and write them down right now. What are the slopes of the lines in number 2? And then circle the 2 slopes that you believe are going to help you identify perpendicular lines.
Next one's easy.
Now I get the first one has a slope of 2, the second one has a slope of 1/2, and the third one has a slope of negative 1/2. Okay. So I'm going to look at that 2 and I'm going to say, what's its reciprocal? 1/2. 2 is positive though, so then my 1/2 has to be negative. They have to have opposite signs and they have to be reciprocals. So the 2 that are m equals 2, m equals negative 1/2. Those are the 2 slopes that are opposite signs and reciprocals. So we're going to say that y equals 2x plus 2 and y equals negative 1/2 x plus 2 are perpendicular. JC,
Why would you pick a negative?
okay? Because we need them to have opposite signs. So because the first one is positive, we need the other one to be negative. And then we know that once we've picked out our 2 equations, now we have to graph them also. So the 2 that we chose, we have to figure out their starting points, and we have to graph. Remember, again, let me caution you again, because there's always somebody who wants to ignore my cautions. Graph the points for one line, draw the line. Then, graph the points for the other line, draw the second line.
don't both of them have the same starting point?
Yeah, they do. Remember they can have the same starting point. They don't have to, but they can. It's okay. So just let them have the same starting point
I tried.
and see what happens.
So,
And remember, the graphing part should not be the part that we have any trouble with anymore. Oopsie, edit undo, drag and move. Okay, let's try this again. Use the corner of your ruler, use the corner of a piece of paper, use the corner of something that has a square corner, and check our angles out. See if they look like they are. 90-degree angle forming perpendicular lines.
That's how they're used to it.
So that's some of what we're doing in the homework.
I don't like that.
You don't like it? That's too bad. Wish I could, help you
I
out.
do notice that some people aren't, they're putting all their dots on first and then drawing the lines.
How many times did I caution here?
It's really, just put your dots on, draw the line. Put
Just
your dots
believe us.
on.
Put the points for one line, pick up the ruler and draw the line. It's not that hard.
I've been in Algebra 8 for about 8 years, so I've learned.
That's what I did, just do all the dots.
And then put the points on for the other one and draw its line. Otherwise, you're gonna have points and you're gonna be like, I wonder where my ruler should go through. That's why I cautioned you more than once. I should have worn yellow today. Caution! I wore red. Maybe stop and listen to me. And Mrs. Gruffiston, we know what we're talking about. I've been doing it I've been in Algebra 8 for even longer than 8 years. Okay? Okay, so any concerns on this side before we move on to what we have to do on the other?
I don't like
Let's go to the back side. Okay, we're just gonna kind of quickly read through this because this should be something that we're very familiar with doing. It says, write an equation in slope-intercept form for the line that passes through. So here we are, we have this given point again. So they're gonna give you a point that we have to write an equation that goes through it. And they're going to give us a line again, a given line. But this time we have to create a line that's going to be perpendicular, not parallel. We're working with perpendicular now. So here's the most important step in this one. Hear me. Stop. I have my red on. Hear me. You have to be able to identify the slope from the given line, because then you're going to say to yourself, oh, the slope of the perpendicular line can't be the same thing. It's got to be opposite sign and reciprocal. So that's what they did here. They said the slope of the given line is 2/3. See, it's right there. Is 2/3. So the slope of the perpendicular line has to be 2/3 is positive, so it has to be negative, and the reciprocal of 2/3 is 3/2. So then look at what they did. Same thing we did before. Okay, here's the slope of my new line. This is the new line here, you guys. Would you write that in your notes? This is the new line here that they're doing. Our slope, we figured it out what it has to be, so it'll form those right angles. It has to go through that point. We know how to put it in point slope form. We just did a whole bunch of that, again for today with parallel lines. And then we put it into slope-intercept form. Okay, let's go do one of these together. Write an equation in slope-intercept form for the line that passes through 8, -1. Would you just write that down right now, please? 8, -1 is the given point. And it says, and is perpendicular to the given line, so we have y equals -4x minus 7 is the given line. Why do we care about that given line? Well, because we want a line that's going to be perpendicular to it. What do we need to know from that given line?
Slope.
We need its slope, don't we? We need to say, oh, okay, your slope is -4. So now we're going to say, let's just start a new line. M equals what? What's the slope got to be for the new line then?
Has to be.
What's the reciprocal of 4? What's the reciprocal of 4, class? 1/4. What's the opposite sign of a negative? Positive. So the slope of the new line has to be a positive 1/4. 1/4, yeah. Well, we now have, we're working with our new line, you guys. I probably didn't do a very good job of setting that up there. We have m equals 1/4, and we know that we have to go through the given point, which was what again? 8, -1. What's step 1? Point, slope, form, right? Put it into this point, slope, form. So we need this to be our x sub 1 and that to be our y sub 1. And we're going to substitute into our point, slope, form. So, y stays y. What's going in for y sub 1?
-1.
-1. What's going in for m?
1/4.
1/4. X stays x. What goes in for x sub 1?
8.
8. Let's change subtraction to add the opposite, and then if you, I'm going to move over because I'm guessing you're writing down in the bottom of your page too. So y plus 1 equals 1/4 times x plus -8. Making it more friendly to work with. That's all we're doing right there. So we're working on our new line. And I'm going to move over so I have some room to finish. What do we do next?
Multiply.
Multiply. We do that distributive property. So we take the 1/4 times each of those in our parentheses. -2. A fourth of 8 is 2. A positive times a negative is 8. Yeah, now we subtract 1 from both sides. That's right. Subtract 1 from both sides.
Then y equals 1/4 x plus -1.
1/4 x plus what? -3. Kind of like, you can kind of think of it like this. It's 2 below 0. The temperature just went down another degree. So now it's -3. So here's the equation of our new line. That's one of the things we did, just like we did for today. We had to come up with the equation. And now what do?
Simplify.
Yes, Dakota.
Y equals 1/4 x minus 3.
Okay, cleaned up it would be y equals 1/4 x minus 3. Okay, and I kind of left it in this form for us for graphing, but yes, that's what it would look like cleaned up. So, let's go graph our given line first, okay? And we have a graph here. So our given line. What else do we need from our given line? Well, it sure would be nice to know what the b is. What's our b?
7.
-7. -7. We got to start in the right place. And then make sure you graph your slope correctly. And after you make the points for that one, what are you going to do? Draw the line. You're going to draw the line right now for this given line. After the given line is graphed with a line, not just its points, now you move on to the new line. We know its slope is 1/4, and we now know its y-intercept is what? -3. Okay, so we have a slope of 1/4 and a starting point of -3. Remember that they can start at the same place, but they don't have to start at the same place. I should be using a different color. Positive 1/4. Make enough points so that you can get a good line. And then you do what? Now, what's the last thing you do after you have this line graph?
Right arrow
Yeah, what else do we do?
Put the ruler on the.
No, we put nothing, yeah, maybe that's what you're saying, put the ruler in the corner? Or a piece of paper in the corner, you check to see do we have right angles? I've just looked at the paper, I'm not sure they turn out to be right angles. But I'm feeling pretty good about mine, are you feeling pretty good about yours?
Yeah,
If they don't make right angles, is there an issue?
yes.
Yeah,
It's best to
there
get a
is.
protractor.
Well, not necessarily, you can, if you wanna measure them with a protractor, you can, but you don't have to. But if you can't budge and say, close enough, make sure they are what appears to be 90-degree angles, okay?
Get us 90 degrees.
So, anybody have questions or I need to see something on here that you didn't keep up with? Okay. Then what I'll do, there is actually white space on here, so I guess if you want to show your work on here, you can, but I'm thinking that line paper might work better for some of us. So you